Hello, welcome to Zigmatech Learning Hub. I will be your instructor for chemistry. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WEAC, GCE, KCPE, IJMB, JUPEB, Calbepedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Today's lesson, we are going to be talking about matter. It's a continuation of the previous class, matter. So this is the part 2 of matter. Now, in today's lesson, objective, by the end of this chapter, you will know the physical differences and characteristics of the classical states of matter, the physical similarities between the classical state of matter, and the theoretical explanation of the man-made and the natural state of matter. Now, differences and characteristics of the classical state of matter. Now, these differences are basically the characteristics too, because this is what makes them different from the other. It is their properties. Okay? It is what we know them for. So the first one said solid have high density, liquid has less density, and gas has low density. Density is its mass, an object's mass per unit volume. Okay? The mass of the object occupying a particular volume, that's density. Now, the solids have high density. They are more heavier, they have more mass, and they occupy more volume than the liquid. That's why the liquid has less density. While the gas has the lowest density. They do not occupy spaces as much as the solid and the liquid. And they don't have volume. They don't really have mass. Okay? When you put them in a container, like a gas cylinder, the mass is being calculated with the cylinder and the gas inside. So their mass is not constant. It's not that they don't have actually, but their mass is not constant. They don't occupy a particular volume at every given point in time, unlike solids and liquids. And that is why they have very low density. Now, the second one said rigid and cannot flow. Because they are rigid, because they are strong, okay, they cannot flow. They cannot move easily except they are being pushed by force, either a contact force or a non-contact force. Now, the liquid say less rigid and flow easily. I told you that a liquid is a free-flowing substance. Now, when they say less rigid, in essence, their rigidity is lesser than solid. Now, you begin to imagine, rigid means strong. How can a solid be strong and flow easily? If you pour a solid on a flat surface that has no slope, the solid moves slowly. At that point in time, it is strong. The solid moves slowly. It does not move so porously as of when the place is slopy, as of when the place has a slanty nature or a slanty culture. You know, so the rigidity of solids can be examined or can be seen when you pour a liquid. The rigidity of liquids, will be seen when you pour a liquid on a flat surface. Then you can see they will now fighting, they will now be resisting flow. Why? Because their rigidity is being experienced at that point in time. Now, this one, no rigidity and flow vigorously. They are not rigid. Anyhow you bring them out, they flow. That is why they do not have a specific mass, they don't have a specific shape, and they don't have a specific volume, because they flow vigorously. They flow indefinitely. Okay? Now, the next one is have fixed shape as well as fixed volume as well as mass and shape. The liquid have fixed volume, mass, but no shape, while the gas has no shape, no mass, and no volume. Now the solid have fixed shape, fixed mass, and fixed volume. They are fixed. That is why the law of solid states that it is always fixed in its position. Because of the fixed mass and because of the fixed volume it has, it is always fixed in its position. Now the liquid has fixed volume, mass, but no shape. Their shapelessness is because of their free flow. That is why a liquid is shapeless, because of its free flow. Now the next one says no fixed shape as well as mass. Like I told you, it does not have a fixed shape. Okay? It does not have a fixed mass and it does not have a fixed volume. Now the particles are tightly bonded together in solids. Particles are less tightly together in liquids, and particles are loose. Now in the solid, the particles are tightly bonded together. That is why they have a fixed shape. Because the particles are together. These particles, like I said, are molecules. We will talk about molecules more when we get to the particles of matter. So the particles are tightly bonded together. That is why they have a fixed shape. They have a fixed mass and they have a fixed volume. They are bonded, they are closed. That is why you see them, they have a shape. So particles are less tightly together in liquids. The particles are less tightly together in liquids. That is why they do not have shape, but they take the shape of a container because their particles are less tightly. So the law of liquid states that it always conforms to its container. Then the gas, particles are loosed. They don't have a fixed shape because they are loosed. You know, take for example, you blow particles of chalk in the air. Okay, you see how they will be scattered. They will never form any shape. They will never form any shape. In essence, if they don't have a shape, they cannot give you a particular mass and they cannot occupy a particular volume at a given point in time. Their particles are not fixed. They have, but it is not fixed. If they occupy a volume of 25 kilogram in this container, by the time we transfer it to another container, it will be lesser because in the transferring, they escape vigorously. Their particles are loosed, so they are not clinched together. Now, these are the physical states. These are the physical state of matter, their differences. The classical states, I told you why they are called classical, because it's something we experience in our day-to-day lives. Okay? Now, when we get to the kinetic theory, you will know the kinetic explanation and the kinetic differences of solid, liquid, and gas. Now, the next one is the similarities between the classical state of matter. The similarities, what is making them similar? One, they say they are all states of matter. They are all states of matter. Okay? The next one says they all undergo changes. The solid can change to liquid, liquid change to gas, gas change to solid, vice versa. So, in this context, we will talk about more on their changes, how they change, how they undergo their changes in the kinetic theory of matter. I want to talk about change of state. So I urge you to follow this lesson simultaneously so that you get every detailed information you need to know. And if you get this detailed information, you need to know distinction will be your name. And I know that A1 will be your culture. Every exam you write, you come out in distinction. Just try to follow the lesson as it's going, because chemistry is not something that you just do. Okay, we have the science has methods. Like I told you in the introduction to chemistry, how science works. They have methods. Okay, they start from 1, 2, and 3. So you just have to follow up. Now the last one in the similarity says they all have density. Like I said, they all have mass. They all occupy space, volume, particular volume, and they make themselves available in every container. They occupy a volume and they have mass. But the difference, like I said, is that one has not, the issue is that they are not certain and they are not definite apart from the solids and sometimes the liquid. Now, let's go to the next state of matter. The next state of matter, we'll talk about the classical states, we'll talk about the physical states. Okay? Now, this is the man-made state of matter, the man-made category of matter, which is the BOSE-EINSTEIN condensate. the BOSE-EINSTEIN condensate. As you can see on the screen, the formation, how it was formed. It said in 1995, using of combination of lasers and magnets, Cornel and Carl Weiman in Boulder, Colorado, cooled a sample of rubidium to with a few degrees of absolute zero. At this extremely low temperature, molecular motion comes very close to stopping. Now, rubidium is a white silver-line solid. Okay, it's a white silver-line solid. A metal is a solid. White silver-line solid. Now, if you're cooling a solid, it turns more solid. It turns stronger when you're cooling a solid. Now, as this rubidium is being cooled, okay, as this rubidium in being cooled with the combination of lasers, a laser is an acronym of light amplification of stimulated emission of radiation. A laser is an acronym of light amplification of stimulated emission of radiation. That is a laser. Now, using a laser, using radiation, this rubidium was cooled below temperature. And as it's been cooled to absolute degree, absolute few degree of absolute zero means freezing point. You know, below its freezing point. Below the metal's freezing point. That's what you're talking about. So now the metal is being freezed below its point, below the freezing point. And as it's being freezed, it turns more solid. Okay? And it's turned more solid. We know that one of the characteristics of solid is that their particles are bonded together strongly. They have a strong bond in their particles. So these particles get more rigid and stronger. In essence, the molecules refuse to move. The molecules stop moving. The particles stop moving. They say molecular motion. You know, when the particles move molecularly, it's called molecular motion. So the particles stop moving. Now, when they stop moving, they occupied spaces in rubidium. When they stopped moving, they started occupying spaces. But rubidium, you know, can turn into liquid at ambient temperature. Ambient temperature is a temperature that is familiar with your environment, with the air, okay? But it will be at hot. It is when the environment is hot. That is when rubidium can turn to a liquid. But in this case, so in essence, if rubidium is being cooled and freeze, it will turn to solid, more solid. So this motion stopped. So those particles now occupy the space of the rubidium. In essence, the particles of rubidium occupy the spaces. Do you know that before they will clinch together, it is particles that will clinch together. And those particles must have to occupy spaces. It's like you buying a cube of sugar. You see that there are particles that came together to form that sugar. If you scratch the sugar, you see the particles on your hand. And those places that the particles left will have holes. So in essence, these particles you see occupy the spaces of that sugar and gave them a shape. That's the same thing that happened in this BOSE-EINSTEIN condensate. Like I said, the laser is an acronym. Okay, now, what is an acronym? Let's know what an acronym is. An acronym is a device that emits light through a process of optical amplification based on the stimulated emission of electromagnetic radiation. So, this particular device emits the laser. Because a laser, like I said, is an acronym. In essence, it is a device. Now, that device is an acronym. That device that emitted this radiation is an acronym. Now, what is an electromagnetic radiation? What is an electromagnetic radiation? An electromagnetic radiation is an electric and magnetic disturbance traveling through a space at the speed of light. Now, that disturbance you see there is a wave. Because a wave is a disturbance of energy in motion. A wave is a disturbance of energy when it's been traveling. Now, the space there is the ATA, traveling through a space called ATA. ATA, that is the space where radiation travels. In essence, the speed of light is the velocity of light. The rate at which light flows is called the speed of light. And it's been calculated at 299,724,454 meters per second. I say it again, 299,724,454 meters per second. It has been approximated to 300 million meters per second. So any of these you use, you are correct. Now, like I said, the disturbance is a wave because radiation is the transmission or emission of energy in form of wave and other particles through a material medium. So, how do we detect radiation? Which instrument is used in detecting radiation? It is called the gigamolar. The gigamolar detector is used in detecting radiation. Be informed. The gigamolar. That is what you use in detecting radiation, the GM. So, now, the next one is, what is the BOSE-EINSTEIN condensate? You've known the formation. Now, what is it? The BOSE-EINSTEIN condensate is a substance that no kinetic energy is being formed from atom to atom. Like I said, when this rubidium is being done, they are clinched together. Now, when they clinch together, they stop moving. In essence, there's no kinetic energy. Because kinetic energy is energy in motion. Energy you possess in motion. So when they are clinched together, when this rubidium clinched together, they now occupy the spaces of that particular substance. When they occupy the spaces of that particular substance, they stop moving. In essence, they become constant. They stop moving. They are just there in a position, in a state of rest. Like I said in the sugar. The cube of sugar, the particles are in a state of rest, and they are occupying spaces. And those particles can be called atoms. Why? Because the sugar is an element, and the small particles becomes the atom that made up the element sugar. So in this BOSE-EINSTEIN condensate, we can say sugar, particles of sugar is an example. Okay? Because kinetic energy is not being formed from atom to atom. Now the next one is the photonic molecules. These are the natural states of matter. Let's go to the natural states of matter, the photonic molecules. You see how they are displaying. Okay? You see the three colors. You see the three colors. Okay? One is a positive charge, one negative, and the other has no charge. The blue positive, the red negative, and the other color is the neutral. That are the photonic molecules. Now, they said they are formed when individual massless photons interact with each other so strongly as they act as though they have mass. I told you that matter, everything in life, everything we see do not have mass. Not everything have mass, but everything occupies space. Not everything have mass, but everything occupies space. We've seen two states of matter that are massless. One is the plasma, and the other is the photonic molecules. Okay? Now they are formed when individual massless photons interact with each other as though they are strong, as though they have mass. Now, you see how they are interacting. You see how they are interacting together. The photons come together. Okay? They come together, they interact. As they're interacting, they are occupying spaces in their interaction. As they interact, they're occupying spaces in their interaction. It's like me coming to shake you. Okay? As I shake you, I have occupied the space in your hand, and you have occupied the space in my hand. Because as I'm holding you, shaking you, I cannot hold any other thing anymore. So when this interaction comes, as if they have mass, they interact, they are discussing, they are playing, as you can see on the screen. They are playing, but they are massless. Why? Because they are floating. As you can see, they are floating. Okay? So anything that is floating is massless. Now, what is a photon? Let's know the things that are interacting as though they have mass. Now, a photon is an elementary particle, comprises waves of electromagnetic radiation. Now, these particles come. I told you that radiation is the emission or transmission of energy in form of wave or other particles through a material medium. Now, they say the photon is an elementary particle comprises of waves. In essence, those other particles can be a photon of electromagnetic radiation. It comprises of waves. So as the photon, elementary particles are charged particles. Okay? The elementary particles are charged particles. As you can see on the screen, you see how they are bringing out their charges. When they collide, the charges come out. When they interact, the charges come out. So those charges now occupy spaces. Let's take, for example, electricity. Electricity. The electricity flowing, the current flowing, the electric current flowing in a wire is massless. You cannot calculate it. The only time you can know that something is occupying the space of that wire is when you go and hold an exposed wire. Then you go to church and give a testimony on that. You will now know that something is really occupying the space in that wire. Now, those particles that occupy the space in that wire are charges, and they can still be called photons. So, and this photon, these photonic molecules has occupied the space in that wire. The second one is radiation. When radiation comes with electric charges. Okay? When they say electromagnetic, in essence, it is electrical and magnetic. It is the vibration of an electric field and a magnetic field that forms an electromagnetic radiation or electromagnetic wave. Either you call it electromagnetic radiation or you call it an electromagnetic wave, because radiation comes as form of wave. So, in this particular thing, like I said, the radiation that comes in form of wave burns you. When it touches you, you see the hotness of it. And that heat of radiation is called radiant heat. It touches you, the heat touches you. Why? Because it's electrical. That is why it's hot. Every hot object is electrical. Now, the next one is the superfluid. The superfluid is an exotic state of matter with unusual properties that has zero viscosity. Example, liquid helium. It has zero viscosity. Zero viscosity means inability to flow. It's inability to flow. So it says it has zero viscosity. In essence, its inability to flow is zero. That means it flows. A fluid is any substance that deforms under shear stress. That shear stress is force. So when force is applied on a fluid, it deforms. It loses its shape. Okay? It loses its physical properties. And fluids are subsets of liquid, gas, and plasma. So in this context, this particular superfluid is a liquid. Why? When helium is being cooled, it changes to liquid. When helium is being cooled, it changes to liquid. So in essence, it is the helium they used in the process of discovering a superfluid. And the superfluid was discovered by Piotr Kapista. Piotr Kapista discovered the superfluid. As you can see on the screen, they are cooling the superfluid. And as they are cooling it, it is changing to liquid. So this is what a superfluid is. Now the next one are superconductors. Superconductors, discovered by Zhang Wang, discovered as superconductors. Remember, the photonic molecules were discovered by Johannes Rydberg. I didn't tell you that. The photonic molecules were discovered by Johannes Rydberg, a Swedish chemist. Now, the superfluid is a state of matter that at low temperature exhibits zero resistance to electrical current. Every single metal at low temperature becomes a stronger solid. At low temperature, copper oxide is a solid. At low temperature, aluminum, iron pnictides, magnesium diborides are all solids at low temperature. Now, the copper we know, you know that copper are conductors. Okay? They said at low temperature, zero resistance to electrical current. In essence, when the copper is at low temperature, it is not a resistance to current. Anything that passes through it must have a free movement. Now, these conductors occupy spaces, like I said about the electric current. These conductors occupy spaces. The copper is just a conductor. Okay, now a conductor is a material that allows the free flow of electrons from particle to particle. A conductor is a material that allows the free flow of electrons particle to particle. Electrons there are charges. Electrons there are electrical current. Now, anytime you hear electrons, it talks about electrical current, electric charges, electricity, except in a case where they are talking about differentiation of charges. That's when electrons become the negative. Because the H plus the H minus will give you H minus. You know about that when we talk about the particles of atom. Now the next one is the quark-gluon plasma. The quark-gluon plasma. It is made up of quark and gluons. Now, quarks are elementary particles that make up the protons and neutrons that in turn make up the atomic nuclei. I will explain this particular thing constructively when we talk about the atom. But in this case, I'll just have to explain it a little bit. Now, the elementary particles, okay, are small particles. When they say elementary, they're talking about the small particles that make up something. You know, the atoms has particles that are the protons and neutrons, and every particle is made up of particles. Even the smallest particle is made up of particles. So these particles are made up the protons and neutrons. Protons are positive and neutrons are chargeless. That turn out to make up the atomic nuclei. Both of them are found in the center of the atom. Now, a gluon is a tiny particle that acts as an exchange particle for a strong force between quarks. Now, that force that binds these particles together is a gluon. Now, that tiny particle that exchanges himself so that there will be a force to bind these particles between the quarks is called a gluon. Now, let's know what a quark-gluon plasma is. It's also called a quark soup. Now, the quark-gluon plasma is a state of matter in which elementary particles that make up the hadrons of bionic matter are freed of their strong attraction for one another under extremely high energy densities. This definition is long, I know, but let's see how it is going to be shortened. Okay. Now it's a state of matter with elementary particles that make up the hadrons of bionic matter. Now, these small particles make up the hadrons of the bionic matter. I told you that states of matter, it is called a soup because it combines two things together. It is only the state of, it is the only state of matter that has two things together, that has two particles together, that has two phenomena together. Now, when you're cooking, that's why it's called a quark soup. When you want to cook soup, you know, there are so many things you bring together. You buy a goosey, you buy fish, you buy meat, you buy the periwinkle, you buy so many things. Bring them together for you to have a good soup. Like my friend will always call it good soup. For you to have a good soup. So in that process, you've got yourself a good soup because it is a combination of items. It is a combination of products. It is a combination of market things you went to the market to buy that will give you a very good soup. Like where people will say, good soup, na money killer. So these particles, like I said, elementary particles that make up the hadrons and the bionic matter, I'll tell you what the hadron is and what the bionic matter is, are freed from their strong attraction for one another. In essence, the particles that come, okay, the gluons that exchange themselves for this, the quarks are being freed from this particular thing at extremely high energy density. So when the energy is high, okay, when their mass and volume is high, they spread out, as you can see on the screen. When their mass and volume is high, they spread out. Example is the protons and the neutrons, the charges. Okay, when you on an electrical apparatus, okay, there is a force that pushes the current from point A, which is the socket, to point B, which is the material that you want to be lightened. Now, as that force comes, it frees the electrical current. It frees the protons and the neutrons. It frees them. And as it frees them, the current flows. The current moves. Okay? The current moves as it likes in a speed, causing friction. Now that friction will bring heat. And that heat produces the light you want. So that attraction are free from their strong attraction for one another. So that attraction between the protons and the neutrons will be freed because of this quark-gluon plasma, because of this state of matter. Now, when this state of matter occupies is being effective on this particular particles, the current covers. As it covers, you know, is occupying the space, as you know that. Now, let's know, besides, it's going to be at high temperature, high energy density, high one. Now, I said I will tell you what the hadron and baryon means. Now, a hadron is any of the subatomic particles that made up the quarks and are subject to strong force. Those particles that make up the quarks and they are subject to strong force, they are available to strong force. They must have to have a strong force for them to operate. Subatomic means smaller than atom. Okay? You will know that when we get to the atoms. Now, there are small particles that make up the quarks. You know what a quark is. I've told you what a quark is already. So these particular particles that make it up, okay, and they are subject to force from the baryons are called hadron. Now, the baryons are heavy subatomic particles that are made up of 3 quarks. What are the 3 quarks? Okay, the 3 quarks are the particles of matter: the proton, the neutron, and any other particle. These are the 3 things: the proton, neutron, or any other particle. Now, they are heavy. That is why they can be able to force the hadron. Okay? They must have to be heavy. That is why they will be able to force it. Now, if, let's take for example, you want to push a boy, you must have to have more mass than that boy, except you cannot be able to push it. Your mass must be more than the boy. And if you want to push an object, okay, you must have to have enough force that can be transferred to that object for distance to be made. Otherwise, that object cannot move. So these baryons must have more mass than the hadron so that they can be able to push. Now, when they push these particular particles, the particles will have to make a movement. And as they're making the movement, they're occupying spaces in that particular vacuum they are going through. And as they are going through, they are occupying the spaces. And those things, they are occupying those spaces, they are states of matter. Because I said matter is anything that occupies. Now, those particles that occupy those spaces as they move, because of the force that is being acted upon the hadron, is called the quark-gluon plasma, or the quark soup. Now, let's go to the exam guide. Okay? We'll go to the exam guide, chemistry, let's go to the year 2013. 2013, question 1. And it says, which of the following instruments is used in detecting the presence of radiation? Which of the following instruments is used in detecting the presence of radiation? We talked about radiation in the BOSE-EINSTEIN condensate. Okay? We talked about radiation in the BOSE-EINSTEIN condensate, in the formation of the BOSE-EINSTEIN condensate. Now, we said that radiation is the emission or transmission of energy in form of wave or other particles through a material medium. Now, when this radiation comes, okay, but there are sometimes when this radiation comes, how do we detect it? Because sometimes you do not see the radiation. You do not see the rays of light of the radiation. Because radiation is what helps us to see. Radiation is what helps our vision. Okay? Now, when radiation hits the ground, the reflection comes to our eye and it enhances the sensation of vision. So, and radiation most times comes from the primary source of energy, which is the sun. So now, how do we detect this particular thing? I told you it is by the gigamolar, the gigamolar apparatus, the gigamolar detector. Okay, I told you that that is what is being used to detect radiation. Now, if you check, the first one it says a cathode ray tube, no, the gigamolar counter. Either you call it the gigamolar detector, the GM detector, or you call it gigamolar counter apparatus, anyone you're correct. So the answer there is B, the gigamolar counter. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it. Bye.